Oh, welcome and thank you for joining. Let's take a look at another example where we practice how to use the second derivative test to identify the minimum or the maximum point on the graph of a function. Now, just to refresh your memory, we said that the min and maximum points happen at the critical points on the graph of a function, and they're both found by making the first derivative equal to 0. So to identify whether at the critical points the function will show a min or a max, we look at the second derivative. So at the minimum point, the second derivative will be positive because minimum is located at a concave up interval, and at a maximum point, the second derivative will have to be negative because the maximum is located at a concave down interval. So in order to identify or determine the critical points, we have to start off with the first derivative. First derivative in this case will be equal to 6x to the power of 2 minus 30x plus 24. So simple power rule in here. Now, the critical points are found at wherever f prime equals 0. So that means that we're going to try to make 6x squared minus 30x plus 24 equal to 0. So let's see if we can factor this. So first I will try to simplify or reduce the coefficients. So we have a common factor of 6 throughout the equation. So divide every term by 6 and then we get x squared minus 5x. 24 over 6 is plus 4 equals 0. It seems that we should be able to factor this, so x minus 4, x minus 1 equals 0. So therefore, we'll say that the critical points are at x equals 4 and x equals 1. So far we have just identified the critical points, so they can be either min or max, we don't know yet. So to find whether they represent a min or a max, what we do is we check the value of the second derivative at the critical points, which means that we have to start off by finding the second derivative. So the second derivative, f second x, would be equal to, so always refer to the first derivative. So we have 6x squared, derivative of 6x squared is 12x. Derivative of negative 30x is minus 30, and derivative of the constant is 0. So in order to determine whether at x equals 4, the function shows a min or a max, we have to find the second derivative at 4. So, which means that we're evaluating the expression 12x minus 30 at 4. So 12 times 4 minus 30 would be equal to 48 minus 30, and that equals 18. 18 is a positive number, therefore the function will be concave up at x equals 4. Concave up means that the function or the point, the critical point, will be located at a lowest point in this interval, which means that it will represent a min. Now, in a similar way, we check the second critical point, so x equals 1. The second derivative here will be 12 times 1 minus 30, so 12 minus 30 equals negative 18. So that's negative. So what that means is that the second derivative is negative, which makes the shape of the graph or the concavity a concave down, which means that the graph is going to look like this at the point where, or in the interval where this point is located, which tells us that at x equals 1, the function will show a maximum. So therefore, we're going to say that at x equals 4, the function will have a maximum. Let's find out what the y-coordinate would be. So for the y-coordinate, we simply substitute x by 4 in the function. So that would be 2 times 4 to the power of 3 minus 15 times 4 squared, and then plus 24 times 4. I will simply use the calculator here to find the value of y. So that would be 2 times 64, that's the 4 to the power of 3 minus 15 times 16, and then plus 24 times 4, and that will give a value of negative 16. So At x equals 4, y equals negative 16, the function will hit a minimum. And at x equals 1, the y value when x equals 1 is found simply by simplifying the coefficients. So we have 2 times 1, 2, minus 15, negative 13, plus 24, 11. So 1 and 11. The graph of the function will show a maximum. So it becomes easier with practice, if you notice. So you can practice a couple of questions from the homework. It's not that difficult, and you will have a similar question on the test. So don't be surprised. Well, thank you for learning with me, and bye for now.